cost. All right, as always, examples. That's how we learn examples. So we're going to start with log base 5 of 3x plus log base 5 of 4. I don't know why I put 4 in parentheses there. Oh, I'll just stay consistent. I'll just keep doing it. Equals log base 5 of 32. Well, that way there, you'll be used to whatever you get. So sometimes there's parentheses around the arguments. Sometimes there's not. Like I would always put them around the 3x since it's a double, but the 4 and the 32, I don't know why I did that. So this is new, but the one thing that doesn't change is step 1 is still like yesterday to condense. And so you see that you have 2 logarithms over here on the left-hand side. So we have to condense them into 1. What's that going to be?
Base 5.
12x. So, I mean, that's something you should already know how to do from a previous lesson yesterday, maybe the day before yesterday. Yesterday. So when you condense 2 logs, remember you can condense with times if it's plus or divide if it's minus. So this is one new topic for the day. These will become your favorites because you don't have to convert these using the water cycle. There's a property in math that if you have logs on both sides of the equation, you can actually just drop the logs completely out. And so this equation, the logs become irrelevant because the log base 5s match. So the idea is that if log base 5 of something equals log base 5 of something else, then quite simply put, the something just has to equal the something else. So I will say the drop the logs. I mean, that's kind of the way the verbiage has evolved over the years is we just drop the logs. And so the logs become meaningless provided that there's 1 on each side and nothing else. So if there's an extra log, which we would talk about that if that happened, then we'd have to get creative and maybe like bring them to one side and recondense them or something like that. But in a case like this, simple single log equals simple single log, get rid of the logs. And then it instantly goes from a high school level problem down to like a 7th grade math problem. Divide both sides by 12 and you get your answer, x equals, and those can both divide by what, 4, giving you 8/3. Now, as we saw yesterday, it is our job to check every answer. So we have to take 8/3 and go back to the original problem and just verify that it's not going to make any bad arguments. And remember, the arguments of logs, log of 0 is bad, and log of a negative is bad. And so if either of those things happens, then you get rid of that solution. But 8/3 is obviously going to be just fine because it makes a positive number. So we can box it up and that's that. So that the idea, the reason that example is there is because I wanted you to learn how to drop logs when you have 1 on each side and nothing else. Okay. So the next couple of examples will be based pretty much on that idea. So let's keep pressing and then we'll move on to the natural logs. So log base 11 of 4x minus 3 minus log base 11 of 2x equals log base 11 of 10. What do we do? Yeah, condense, right? So we condense into a single logarithm on the left-hand side. These two, since there's subtraction in between them, will condense into a single log as a division problem. So it's going to be 4x minus 3 over 2x. And then what you learned about 2 minutes ago can be put to use here. We have matching logs, and so we just eliminate the logs. And that's when it instantly transforms into a very, very, very basic algebra problem. So we wind up log base 11, and we're just left with this equation. So 4x minus 3 divided by 2x equals 10. And then our algebra training kicks in. We're no longer going to think of logs. We're just going to solve. We multiply by 2x. C fraction, kill fraction. That's what we do. The 2x's go bye-bye. And we're left with 4x minus 3 equals 20x. Guys, still good? Is easy algebra, right? And then I don't really know what your approach would be. It's kind of six of one, half dozen the other. I'd probably just move the 4x over to the right, giving me -3 equals 16 x's. And then I would divide and I would get x equals -3/16. So remember, no naked answers, like answers for these types of equations, should not be left untouched. They should either be boxed up to state I have checked it and it works, or they should be crossed out to state I've checked it and it doesn't work. No naked answers. And so you're going to take -3/16 and you're going to put it back up in the original problem. And you can see right away, Houston, we have a problem. If you put it into either of these purple arrows, you're going to get a negative argument, right? You can see that either one. And so for that reason, we would cross out the answer. And what would we say? There is no solution. So I think that's the first one of those that we've seen yet, maybe. But it can happen. If your only candidates don't work, you got nothing. Okay. So let's do one more to test this property, and then we'll move on to natural logs and see how that goes. So we have log base 4 of x squared minus log base 4 of 6 equals log base 4 of 9. I tried really hard when I wrote these problems this morning to get a nice sample platter of all the questions that might come up. Will I inevitably miss one little detail? Probably. But once you know the basics, then it's on you to just use your skills and find workarounds. But this is a pretty long note card here. So, all right, step 1, condense, right? So on the left, what do we get?
Oh, base 4.
Log base 4 of
X squared
over 6. Good job. It condenses into a division because it's subtraction. At this point, you just drop the logs. They become meaningless because I could explain why, but I'm not sure it probably might be a little clumsy. So we're going to have x squared over 6 equals 9. And then again, your training kicks in. There shouldn't be any equations like this. You shouldn't graduate from Burns High School and not know how to solve equations. Like you should understand mechanically what to do. Like Kennedy said, multiply by 6. So if we multiply both sides by 6, cancel those, we get x squared equals 54. So our answers are x equals positive and negative the square root of 54. How does that break down? Perfect. So if you break it down into root 9 and root 6, you wind up with 3 roots of 6. So at this point, those are my answers. The question is, answers, right? There's 2 of them. The question is, are either of them going to cause any problems? And so we'll just go back up to where the original logs were. And you can see the only logarithm that has a variable in its argument is right here. And what do we know about this? It's always positive, right? I mean, unless we put a 0 in there, but we don't have that. And so no matter what we put in, a -3 root 6, a positive, we don't care. It's going to come out positive. So these answers pass the test and they can be boxed. So do you have any questions just on that? The idea is if you can make one log equal to one log with the same base, drop the logs, home free, solve the algebra. The rest of this lesson is dedicated to natural logs. So I think this is where it takes a little bit of a turn for the awkward. So let's see how this goes. Natural log of 12 minus natural log of x equals 6. So you have to notice now that it's going to start changing from one problem to the next. Sometimes there's a log on the right side and sometimes there's not. This clearly is not going to be a drop the log kind of problem because the right side isn't a log. You can't drop it if it's not common to both sides. So what do we do first still? We divide, we condense. Yeah, really want to start using that word. So the natural log of 12 over x equals 6. At this point, we have to convert, and it's hard to do the water cycle when you can't see a number right there? What number is right there? Nah, E. Good. Remember that a natural log, I'll erase this for you, is just a log with a base of E. And so there is a number there. And when you do your conversion, your this to the this equals this water cycle looking thing, it's going to wind up saying E to the power of 6 equals 12 over X. And then we just do algebra. I mean, algebra is less of a class at some point. It's just a tool. Algebra is just a set of skills that you have that'll enable you to do math. I mean, so we multiply both sides by X. C fraction, kill fraction. Like there's really not many exceptions to that. You know, 12 over X, that's not working for me. So I'm going to multiply by X and those X's are going to go kaput. My left side over here is going to be X times E to the 6th equals, and then 12. And don't lose your focus. Solving an equation means to get X by itself, solve, right? And so what do? How do you move the E to the 6th? Do a divide. Fundamentally, you guys all understand that there's a little time sign right there. I'll make it purple for you. You can barely see it. It's right there. And that tells us that to get X by itself, we have to divide both sides by E to the power of 6, like this, which leaves us with our answer, X equals 12 over E to the 6th. Like I said, these get a lot awkward because the E is sort of feels like a blocker almost. Like we're used to numbers like 4 and 11 and stuff, but E is like pi, it just sits there. It can be frustrating. So our job is to go back and check that now. By the way, E is roughly, do you guys all have calculators? If you do, find your E button on your TI 30s. The E button is probably by the natural log, your LN button. You should all have a button. Don't pick the uppercase. I always think that's hilarious. Don't do the up. There's a little lowercase italicized E. If you just hit E and hit enter, it'll tell you kind of approximately what E is equal to. E is a number that, like pi, goes on forever. It's about 2.71828. So E is approximately 2.71828. And it goes forever, right? But that's good enough for us because it just tells me that, I need to know that E is a positive number. And what I reasonably understand is that 12 over E to the 6th is really small because 2 to the 6th is pretty big, 64. Add some change in there. It's probably closer to like a couple hundred. So this is a pretty small fraction. But what we really care about is what happens when we put it back in. So if you take 12 over E to the 6th and you put it here, where the green arrow is pointing, we all agree that 12 over E to the 6th is a positive. And since that makes this a positive, that gives 12 over E to the 6th a pass. And we box it up and send it. So that's the kind of ugliness you can expect for the next 10 or 15 minutes as we do these final examples, is we're going to be toting E's around. It almost feels like E's a variable in the way that we treat it. But it's not. It just feels like it, the way we move it. So next one. They're all natural logs, by the way, from here on out. So let's do natural log of X plus 3 minus the natural log of X minus 2 equals 3. I'm sorry to keep asking this, but it is my job. And I feel like until all 14 of you can answer it in under 1 second, I'm failing you. What is the first step? To condense. Like that is it. 2 logs on the same side, condense those suckers, right? So we're going to condense these 2 logs into 1 as the natural log of a division problem. X plus 3 over X minus 2. Remember, minus condenses into division. Again, this is not a drop the log problem. I've only got, honestly, I think 1 more of those on the note card. So now that you understand the dropping logs thing, then you're comfortable hopefully looking for that when you see it doing that, but this is not that situation. So what is my water cycle converted equation going to look like?
E
Very good,
equals
Kennedy.
X plus 3
E to
over
the
X
third equals X plus 3 over X minus 2.
minus you do multiply by X minus 2.
Right. So we're going to multiply both sides by X minus 2. At this point, it just becomes sort of an algebra nightmare to try to get X now to a point where I can get it by itself. So on the left-hand side, I wind up with E cubed times X minus 2 E cubed equals X plus 3. I just distributed, right? We talked about this years ago, like for you guys, except for you two, I had all of you 2 years ago in Algebra 1, and we did a section on this. It would have been in like October, so it's been a long time, where I asked you this question, and it's a really hard question. To solve for X in this case is tricky. Why?
Okay, that's-
Why is it hard to solve for X? It has nothing to do with the exponents. Listen, normally when I give you an equation and I say solve for X, you should go into just immediate kill mode and say, I'm going to clear everything away from the X, correct? I tried to emphasize the word the. What is the problem with this equation? There's multiple of them. There's 2 copies of him. So the question becomes, how in the world do you expect me to solve for X when he's over there on the west side and he's over there on the east side? Like what gives? Well, what we're going to do is we're going to collect the X terms onto one side and GCF it out. That's how you create a single copy of something when there's multiple copies of it. Is you bring them together and then factor him out. Having said that, here's what it looks like. X is going to come join his homie over here. But then the 2E cubed has to clear and get out of the way. So he's going to move. They're essentially going to switch places. So on the left side, we're going to wind up with E cubed X minus X. And on the right-hand side, we're going to have 2E cubed plus 3. We did that to bring them to the same side so that we can undistribute or factor the X. Right now, there are 2 copies of X, and this is one of the oldest, best tricks in the math playbook is if there's 2 copies of something, put them on one side and factor it out. So you wind up with X times E cubed minus 1. That's a power play to put in your playbook. Take that one with you. Someone says solve for something and it's in 2 different places and they're not the kind of terms you can combine, then you bring them together and GCF it out. And at this point, the algebra is simple. To solve for X, you just divide by what's attached to it. So you wind up with a final answer of X equals 2E cubed plus 3 divided by E cubed minus 1. So I kind of warned you, we're gonna go down an awkward road here. So everybody okay with that? I mean, not all problems are created equal. Like when you're doing listen, the delta math that you're working on is pretty repetitive. Like it's predictable. The worksheet you're going to get tomorrow, you might find one problem that's like super pleasant, and then the next problem might just be an acid spitting demon like this one. So it's just all over the place. That's where it gets, you know that about math. Math gets harder when they're all mixed together. Well, if that one felt good, then you're going to be probably okay from here on out. So let's do this one. Natural log x squared minus 2 plus natural log of 3 equals natural log of 90. What do we notice right away?
It's multiplication.
Okay, yeah, I'm fine with that. So let's go there first. Say again? Yeah, and those are both really good observations. So Kennedy's observation was that there's a plus. So we're going to condense these 2 logs using times. So we're going to have the natural log of 3x squared minus 6. And then Kaysen's observation on the tail end of that is equally important in that now we realize, ooh, there's a log on each side. So what do? You just drop them. Yeah. So I mean, at this point, they don't even have to be natural logs. They could be log base 12, log base 11, log base 36. Like no one cares because since they're the same, they're going to drop. So we just wind up with 3x squared minus 6 equals 90. Just like that, poof, you're out of the land of logarithms. By the way, did we check that last answer? Crikeys. Let me go back and do that real quick. This is a good time to use a calculator. Let's see. What I think you should do is grab your calculator and type in 2 times e to the third plus 3, hit enter, and then hit divided by parentheses e cubed minus 1, close parentheses. I got 2.26. We agree? So if this answer is roughly 2.26, let's go plug that back in and see how it flies. So going back up here, do you see any problem if you put 2.26 right there?
No.
Do you see any problem if you put it right there? Nope, it's close, but it still stays positive, so we're fine. So it passes the sniff test, so we can box it up. I apologize for dropping the ball on that. So, yeah. Okay. So using your calculator is going to be huge. The calculator is not going to do the algebra, but the calculator does all the grunt work. Like it calculates what numbers really equal when you don't want to sit around and try to do it yourself. All right, apologies. Back to this one. So we left the land of logs. What do we do now? Move that 6 over. Get 3x squared equals 96. Next step. Divide by 3. You get x squared equals 32. Next step. Square root that sucker. And you get x equals positive and negative. What is root 32 if you break it down?
4 root 2.
4 root 2. It initially was root 16, root 2, of course. Great job. You just know that kind of stuff by now. So it's time to go back, do our due diligence, and go check those numbers, 4 root 2 and negative 4 root 2. The only place that has an x is right here. And so if you put a number in there, by the way, 4 root 2, if you put it in your calculator, I can't believe I'm about to do this, but if you put it in your calculator, it's about 5.66, just for the record. So can we all agree that no matter what you put in that yellow jelly bean, it's going to be big enough to cover the -2? It's going to be a positive, and it passes the test. So we can box up this and say, you're both good to go. What's nice about those positive negative answers, when you square them, the negative becomes irrelevant, right? You okay? You want a short little break? Can you keep going? Can you keep listening? You okay? All right, press on, then we will. That's how Yoda would say it. Press on, we will. Well, that was a terrible Yoda. Press on, we will. Is it bothering you?
Yes.
No.
Let's ask you a question.
I'm trying to teach you mathematics right now. I'm so sorry that that's on recording. I'm not proud of that. No, I don't have any tissues. Is that what you asked me? No, there's a shortage right now. Is it urgent? Can you wait? Okay. No, I don't have any in the room.
Ready those two, but not as fast.
Oh, you should catch it.
Like,
You're welcome. All right, let's go. Let's finish this. We got some more examples. Let's get this done. Next one. This is example 1, 2, 3, 4, 5, 6, 7. This is the 8th one. 8 out of 12. Let's go. Let's go. No, 8 out of 11. What? What do we do? Condense. Natural log of 24x squared equals 2. Okay, I'll slow down. You're too busy chasing your nose. All right, it's time to do the conversion. Remember, that's called condensing. Now we're going to do converting. What's our converted equation going to look like? E squared equals 24x squared. This one should be more pleasant than that last nightmare. What do we do? We want to solve for x. And so really what we want to do is just leave this red jelly bean alone and say, let's get rid of whatever's by it. Let's divide by 24. So if you divide both sides by 24, you want a square root eventually, but you can't square root until you isolate the square. So we want x squared to equal e squared over 24. And there's a separate lesson that goes with this, and I'm going to make a quick decision here. Let's finish the problem, and then I'm going to take about 20 seconds in my mind and decide if I want to go down this other road. But for now, we can say that x is equal to the positive or negative of the square root of e squared over 24. That answer is mathematically unacceptable, but for right this second with where we are, I don't want to pile anything else on your plate right this second. So for now, I'm okay. Before we take a quiz on this, I'm going to clarify that there's a little bit of extra cleanup work we have to do, but that'll do for now. So let's figure out what that is. If I go into my calculator and I go e squared and I divide that by 24, I get some number I don't care about, and then I want to take the square root of that, and I get about 0.55, just for the record. So that means that this answer is roughly positive and negative 0.55. I just want to know that, so when I go and do my checking, I just kind of have a ballpark as to who are you? Because like right in your current form, you don't mean anything to me. Some weird looking number, but 0.55, let's go put it back in. We're faced with the same thing again. Check it out. What do we know about that yellow egg? It's going to turn positive no matter what we do. Like there's no amount of tomfoolery we can do to make that not true. So we're fine. So this also would pass the test, and we'd say you're good. All right, guys, 3 more. Can you make it? That's 8 down, 3 to go. What's the matter? Are you making debt? Good.
He was calling about the x squared and it's just
Said it's
like
always
always
good.
scared. It's sounds weird. Okay, I get it now. I know what you mean.
All right, this is it. Final countdown. 3 to go. Let's go. Giddy up. Hey, guess what the answer to this question is? What do? We condense, right? So we're going to do the natural log of 2x minus 3 over 3 equals 6. By now, you should be pretty comfortable with condense and convert, condense, convert, condense, convert, right? So let's convert. What's our conversion going to look like? Mm-hmm. And that's just an algebra problem. Algebra is all about just knowing how to move things around and manipulate situations. So let's multiply by 3. That's what any mathematician at this point would do. So we wind up on the left side with just 3e to the 6th equals 2x minus 3. I'm not scared, right? I'm scared of e. It's just an algebra problem. What do we do next? Add 3, so we wind up with 2x equals 3e to the 6th plus 3. Last step. Last step. Divide by 2 and you're done. X equals 3e to the 6th plus 3 divided by 2. My handwriting is on point today. I don't know if you've even taken the time to notice, but I'm just slaying it. Bottom line is that's a pretty big positive number. So if I know it's a big positive number and I go put it back in, it's big enough that when we multiply it by 2, that yellow egg is going to be a positive number. So again, for like the 7th straight time, this answer passes the test and we can box it up. 2 to go. Are you excited? Okay, great. You're gonna love this one. Like when this problem's over, you're gonna say something like, "Can we do another one like that? Because that was fun." Bam. Hey, what should we do first? Hey, let's condense. That's going to be 18x minus 6. I assume you're comfortable with that condensing. I keep wanting to say condensation. I just cannot stop. Right. There's no way that that's the right conjugation of this mathematical condense. It's just no way.
E to the
E to the fourth
18x plus
equals 18x minus 6.
six.
Add 6 to both sides. See, we treat E like a variable because he's not really combinable with stuff, but you're used to it by now because you've been doing it for 20 minutes. So divide by 18 and you're done. X equals,
E to the fourth plus 6.
and again, if you grab your calculator and do E to the fourth, well, let me go take a real easy look and just see if I even need to waste my time. Yeah, I don't think so. We could probably all agree. Like, let's just say conservatively that E was 2, which it's not, by the way. It's a lot closer to 3. But what's like 2 to the fourth power? 16. And 16 plus 6 is 22 divided by 18. So we can agree that this is bigger than 1. And if you put a number that's bigger than 1 where that arrow's pointing, we can agree that this stays positive. So we just keep passing tests. Can you believe it's the last problem? Are you sad?
No, can you just start?
I'm not going to let you be in little cranky britches change my mood. I'll let you steal my sunshine. Let's condense by division. Next step.
60.
Yes. E to the 6th equals 9x squared minus 3 over 3. Multiply by 3.
3. E to the fifth plus 7x squared.
Hey, Kennedy, you are on a roll. I can't even keep up with you. There,
3.
add 3.
3e plus 6 plus 3 minus divide.
Yeah. So x squared equals 3e to the 6th plus 3 divided by 9. And now the last step. Square what? Square root. Hit it with the root. I'm going to box it up, even though I don't know if it works yet. I'm just going to roll the dice. I'm living dangerously here. Living on the edge. I'm just acting, I feel brave. So let's take that answer and put it back up at the beginning. And, I think we're probably pretty safe. Yeah, I don't think we need to check that one, but you're welcome to check it. But e to the 6th is freaking huge. And then you multiply it by 3 and it gets triple huger. So, I mean, Bob,
I don't think that's a word.
whatever. Oh, hold on a second. Wait a sec. Oh, no, there's a square. Yeah, again, the square is going to bail us out. The square wasn't there, we might have had a little issue, but look at that. And we made it with 8 minutes to spare. For the remainder of this hour today, I see the box. I knew it in my mind. You're going to work on your Delta math from yesterday. I noticed you're all at around 0%, 8%. And then tomorrow you'll work on that plus the worksheet. Class is not over, so make sure you get your Chromebooks out and get to work. Yeah, do you want to swing by the office and see if you can get some tissues? So if you guys look on your scientific calculators, you all have a button. Like Kennedy's is a Casio, so she has a button. She had to find it, but hers says like E to the box. In your TI 30Xs, they say E to the X. So you guys don't have buttons that just say regular E, but that's fine because like if I wanted to do like, let's say I wanted to know what like E squared was, then it's really convenient. I just hit this button and then I fill in the X or the box with a 2. But if you just want regular E, you hit your E to the X button and then just change the X into 1. But for all of you, I think it's going to be found. You'll all have a button that says natural log, and you're always going to find your E directly above that. So you guys all have to hit like shift natural log, and then that's where you find your E to a power. Got it? Shanessa, you with me on that one?
If I had a,
Oh, did I hit resume? Oh, I did. So you have natural log of 6?
no.
Just log
six.
of 6? Log base 6 of
It's 2x squared minus 7 over x plus 3.
Is everything you're saying to me in the argument of the log? So it's 2x squared plus 7
Minus 7
minus 7 over 3.
over x plus 3. Because I already did 6.
Oh, you condensed already and it equals 0? Okay, so what you just have to know is that when you convert 6 to the 0 power equals 1.
Okay.
So you have 1 equals 2x squared minus 7 over x plus 3, and then you multiply.
Yep.
Yep, you good?
Okay, thanks.
Yep.